Hello grade 11s. Today we are going to work with the tariffs and costs of solar and electrical geysers. We will compare the costs, draw graphs and determine the break-even point. All of these will assist in making a choice between the two geysers. Electricity is charged according to a tariff system. What exactly is a unit of electricity? A unit of electricity is a kilowatt hour. Every electrical appliance or machine uses a certain amount of electricity. Buffalo City charges R1.34 per unit. The geyser in most households is the biggest consumer of electricity. We use hot water for bathing and cleaning daily. Eskom has launched a major drive to conserve electricity and has provided an incentive for people to install solar geysers through a rebate system. Let's start our comparison between a traditional hot water system and a solar hot water system. Firstly, let's compare the purchase and installation costs of the two systems. A 200-litre electric geyser costs 5,000 Rand. This cost includes installation and all valves, fittings and labor. Once connected, it will work with electricity. A solar heating system having the same volume costs 25,027 Rand. As mentioned earlier, Eskom offers customers a rebate if they install a solar geyser. This geyser qualifies for a refund of 8,964 Rand. This means that the total cost is 16,063 Rand. This price also includes all pipes, valves and labor cost. Comparing these two geysers and making your choice based on price alone, most people would choose the cheaper one. We will compare what the savings will be if we replace an existing electric geyser with a solar geyser. Before we start our comparison, let's give some background information about solar heating systems. Eskom uses a factor in their rating of geysers called the Q factor. The Q factor is basically a score obtained by measuring how efficiently the sun's energy is converted into heat energy by the solar system. The higher the rating, the better energy usage capacity of the geyser. In other words, it uses solar energy more efficiently. The higher the rating, the more efficient and more expensive the geyser is. The cheaper geysers are more dependent on electrical power assistance for longer periods of the year. The electricity consumption to keep a 200-litre geyser at an average temperature of 60 degrees requires about 11 kilowatt hours per day. Based on the cost of electricity being R1.34 per kilowatt hours, this equals R1.34 per kilowatt hour times 11, which equals R14.74 per day. Now, if this must happen for 30 days, we would calculate the cost by multiplying R14.74 by 30 to give an amount of R442.20 for the month. For the year, this will equal an amount of R442.20 times 12, which is 5,306.40. Let's see what would happen if electricity were to increase by 20% per year. If the electricity increases by 20%, the cost to heat water next year will be 5,306.40 times 20 over 100 plus 5,306.40. 20% equals 1,061.28, which we add to the original amount of 5,306.40. This gives an amount of 6,367.68 for the next year. This calculation is an estimate of what it would cost in a year. We can use this method to calculate the future prices of using an electrical geyser. The same calculation is done for each year, assuming that the increase stays constant at 20% per year. By the 5th year, the cost will be an astronomical amount of 13,950 Rand to heat the water. This table shows the amounts for the next few years as well. Let's compare these facts in a table against a solar geyser system. To have a solar geyser installed, inclusive of all labor costs and fittings, costs 16,063 Rand. This amount must be paid up front before installation. Looking at the table of accumulated costs, it becomes quite clear that the geyser will pay for itself in less than 3 years. If the amount of electricity used each year is added up, after 3 years, an amount of 19,314 Rand would have been saved in costs for heating water. Now let's represent this table on a set of axes so we can find the exact break-even point. That is the point when the solar geyser cost is paid for by the savings in electricity costs. Because the solar geyser does not have any further costs after installation, we can represent the cost as a straight line on the axis. Notice that the cost of electricity represented on the graph is not a straight line. This compounded effect is what is making electricity a very expensive commodity. This curve in the graph is caused from the increase of electricity being incremental. Incremental means that the value from the previous year is used in every successive calculation. It is similar to compound interest. Reading off the graph, we read along the horizontal axis, or the years where the two lines cross, and we get a value of 2,7 years. The vertical value is the cost of the solar geyser. Now, to write this down in years and months, we would determine this as follows. 2,7 years minus 2 full years leaves you with 0,7 years. Now, to calculate the months, we take the 0,7 and multiply by 12, as there are 12 months in a year. This gives an answer of 8,4 months. To determine the number of days remaining, we subtract the 8 months and multiply the 0,4 with 30 days. This gives an answer of 12 days. Thus, we can say that the solar geyser would pay for itself in 2 years, 8 months, and about 12 days. We can conclude that if we can afford the initial costs for a solar geyser, then it is the cheapest option. Thank you for joining us, grade 11s. Remember, the tasks for this section can be found in the Basics of Finance task video. You'll also be able to learn more about finance on our website, www.mindset.co.za/learn. Goodbye.